but they were economists. They were not people who were trained in chemistry or physics.
Great. Super. Well, thanks so much to the organizers for having me here. I'm Dave Keiser, environmental economist at UMass Amherst, and most of my work today has focused on the economics of water quality, especially in the United States. And a key motivating reason for that is that since the early 1970s, we've spent over $5 trillion on efforts to address surface and drinking water quality in the U.S. However, I think it's a fairly agreed upon fact that we have relatively little information on how effective the spending has been, both in terms of its impacts on surface and drinking water quality, as well as economic welfare. And so my research agenda to date has really focused pretty heavily on trying to help fill this knowledge gap, where I've been interested in trying to better understand how effective our clean surface water and drinking water policies have been related, trying to better understand the economic benefits and improvements to surface and drinking water quality. And then lastly, I've become more interested in trying to better understand how information on pollution affects both behavior as well as the value of changes in drinking and surface water quality. And my homework assignment was to provide you with a brief overview of my research, as well as to talk about a key challenge that social scientists face in terms of in this area, and then I'll conclude with the measurement issue. All right, so just to give you a flavor of some of the research that I've done, this is work with Joe Shapiro, where we are interested in trying to better understand the impacts of the Clean Water Act. And in particular, we were interested in trying to better understand how has surface water quality changed since the 1970s using some of the data that Hannah highlighted. Second, to what extent did the Clean Water Act federal grants program contribute to changes in surface water quality? And then lastly, what were the economic benefits associated with this grants program? And what we found is that according to based on the measures that the Clean Water Act targeted, there have been significant improvements in surface water quality in the U.S. The grants program did contribute to these improvements. However, when we look at the benefits of these grants programs, they fall short of their costs. And in some follow-up work, we identified some potential reasons for that, including some potential measurement issues related to trying to measure the benefits of improvements in water quality. And some similar kind of work that I've been doing with Joe, as well as Bashma Zumder and Dave Molitor, we've been interested in asking similar kind of questions about the Safe Drinking Water Act in the U.S. And for the better part of the last decade, we've been contacting individual states to compile and clean their drinking water data, and have been interested in trying to better understand what's happened to drinking water quality in the U.S. and to what extent did the Safe Drinking Water Act's revolving loans program contribute to changes in drinking water quality, as well as changes in human health. And what you see here is that we do see some evidence that drinking water pollution has improved over the last 20 years or so. So those first two papers just give you a flavor, a little of the work that I've been doing on trying to assess major environmental and health statutes in the U.S. But some of my work also is your kind of run-of-the-mill, normal non-market valuation work, trying to better measure improvements or changes in water quality. And one paper in particular that I worked on was trying to link changes in nutrient pollution to changes in water-based recreational use. And what I found in that work was that prior statistical and econometric approaches that have tried to do this likely understate the benefits of water quality improvements due to measurement error in the data itself. So I think that this is also an important measurement issue to think about. And this picture here just shows some potential estimates of what these measurement error distributions look like for measures of phosphorus concentrations across the place. Some other work that I've been doing is focused more on drinking water. And with some colleagues, Peter Christensen and Gabe Lade, we were interested in understanding the economic impacts of the Flint, Michigan drinking water crisis. And what these figures show you is Google search trend results around the time of the crisis. And so that's trying to establish information and awareness of what's happening in Flint. Then we look at bottled water sales and water filter sales, and you do see this kind of averting behavior start to increase even before it was widely widely known that there was actually the lead crisis itself, and so this was in response to signals of potential pollution risk. And one of the things I think is just really unfortunate and even mind-blowing is that even if the Flint crisis had never happened, if there had never been a lead issue and it was just an aesthetic issue, the amount of money that Flint residents paid on bottled water exceeded the expected savings cost from the temporary switch to the Flint River. We do find, though, a negative, sustained, and large decline in the housing market that has not recovered even after water has been declared safe to drink. So those prior studies used large data sets on drinking water quality and surface water quality combined with econometric methods to try to assess the effectiveness of policies and the benefits of water quality improvements. Some other work that I've been involved in is working with a large team of researchers, economists, engineers, and ecologists and others to try to create a national integrated assessment model of the damages of water pollution in the United States. And so you can think of this work as us trying to put a price on pollution depending upon where it's emitted anywhere in the US. And this work is important for trying to inform not only efficient policies locally, you can think about the marginal benefits and marginal costs of water quality improvements, but we've also been interested in trying to estimate gross domestic product equivalent measures of the damages from water pollution. And this has been really exciting to then see the Biden administration pushing forward efforts to help us improve our national natural capital accounts. And so this work we hope will kind of help fill some of the need on water pollution. Other work that I've been moving a little bit more into is I've always been super jealous of development economists because they have these really awesome field studies, and one of the things that I've been trying to do with colleagues from my time at Iowa State is to try to take some of the RCT work that's been done in developing country context and bring that to the US to try to help us better improve our understanding of either information provision or water quality interventions. And so what we've done here is try to improve testing of private wells in Iowa. And we've provided people a pretty simple intervention of just a test strip that allows them to get a decent signal of what nitrates might look like in their private wells. And then we've also conducted a real payment experiment to try to better understand what they're willing to pay for this kind of testing. So that's a little bit of a quick overview of the research that I'm doing. One key challenge that I see for social scientists in this area that is a part of a lot of the work that I've done is trying to better understand how we map water quality to economic value. And it seems really simple, but it is incredibly challenging. So we have questions like, this is a really nice paper from Bonnie Keeler, Steve Pulaski, and others that was back in PNAS back in 2012, and it just shows you that there are incredibly complex linkages between certain measures of water quality as well as economic value. And as an economist working in this area, I want to be able to take some changes in water quality, say changes in total phosphorus, changes in total nitrogen, and link that all the way to changes in economic value, and that's required for me to try to put a price on pollution depending on where it's at. However, these linkages have been really complex, and it's not always clear what's the best way to try to model these linkages. And certainly questions arise as to what are things that people are focusing on for improvements in water quality. Is it the biological community? Is it the aesthetics? Is it what rivers and streams and lakes look like? Is it the use that is allowed in these resources? And I showed you a paper in which I was interested in trying to model changes in water-based recreational use as it relates to changes in phosphorus concentrations. But a key question becomes, is that the proper way to model these things in an econometric study? Should it be phosphorus concentration? Should it be chlorophyll A? Is it Secchi depth? What should the researcher or the econometrician put into their model to try to recover estimates of changes in water quality and how that affects use and value? And how do we communicate this information to the public? What's important for the public to understand potential risks? And so lastly, I'll just conclude that I think a key area of measurement here, and I think this relates to some stuff that Hannah is talking about as well, but I'm always super excited to see Hannah's work because there's always, I feel like normally really cool remote sensing pictures and data that she's using and others are using in this space, but a lot of the work that I've been relying on has been in situ monitoring or ambient measures of water quality, and yet I think that as social scientists we face this issue that even given the data that we have and have had, funding for getting that data has really declined over time. And so the state of Iowa, for instance, the state of Iowa cut funding for water quality sensors in the state. Iowa State stepped in recently to try to help continue that funding, but I'm very curious to hear from you all if there's new frontiers for non-remote sensing monitors, and what kind of opportunities are there going to be in the future for that data. And then I'll just end with a very shameless plug. Sorry to do this, but I'm a co-founder and co-organizer for the Social Costs of Water Pollution Workshop. We're in our 7th year, and so if people are interested in continuing this kind of conversation, we'd like to bring together an audience of economists, ecologists, engineers, and others, and the call for abstracts will be released on Monday, September